By the way, the shortcut for this one is the slope is in standard form is the opposite of a over b. The slope should be the opposite of 5 over 3. So I think that's going to be our answer. But most of you will probably subtract 5x here, so you get 3y equals negative 5x plus 9, and then divide by 3, and you get y equals negative 5/3 x plus 3. So the y-intercept is 3, the slope is negative 5/3, so negative 5/3 is your slope. So if you want to write it in standard form, so you have a choice here. You could do point slope, you could do slope intercept form. I like point slope, so I'm just going to do that one to start with, and then you have to convert it. So its point slope would be y minus y1, which is 2, equals 2/3 times x minus negative 1, which is like boom boom plus 1. So I have to distribute there, so y minus 2 equals 2/3 x plus 2/3. Multiply everything by the denominator of 3. So you get 3y minus 6 equals 2x plus 2. Almost there. Okay, let's get x on the left-hand side, the 6 on the right-hand side. So we're going to subtract 2x and add 6. So we get negative 2x plus 3y equals 8. Bring it over here. Divide by negative, so you get, because you want that first term to be positive, 2x minus 3y equals negative 8. Okay, I'm just going to sketch this out. It kind of makes sense. So 1, 2, 3, 4, 2, 5 is that point right there. I want it perpendicular to the x-axis. So the x-axis is here, so perpendicular would go like this. So that line has an x value of x equals 2. It's a vertical line, so it's an x equals line, and that would be how you do it. Whoops. So use to inspire, use two different methods. There are two different methods. So the two methods are, so method 1 would be to set equal to 0. Then use trace to find the zeros, the x values of the zeros of the graph. Method number 2, graph each side, and you're looking for the x values of the intersection points. I think most people tend to like method number 1 better, but get your calculator out. So we're going to try some of this. So this one, let's set this equal to 0. Let's get that on the other side. So we get 16x cubed plus 16x squared minus x minus 1 equals 0. So I'm going to graph the left-hand side. So I'm going to go 16x to the third plus 16x squared minus x minus 1. Okay, I don't love how close in that is, so I may just adjust. You don't have to adjust your x values, but I'm going to make it like 3 and negative 5. See if that works better. And I'm going to make that 1. Okay, so I don't know if that's a better view for you, but it's at least a little bit better view. So menu 5,1, you don't have to make it a better view. So I can see one of the solutions is at 0.25, one's at negative 0.25. Press enter to lay down a point, and at negative 1. So those are my 3 solutions at negative 1, positive 0.25, and negative 0.25 would be my three solutions. So our solutions are x equals negative 1, x equals 0.25, or 1/4, or negative 0.25. Just to show you the other way, again, you could set that equal to 0, trace, and find, but I'm going to show you the other way if you'd like it better. So I'm going to try this. So this is method number 1 method. We're going to try method number 2, just so you have both methods if you want them. So this one, I'm going to graph both sides. So I'm just graphing a separate equation. So 1 plus square root of x. Hit tab and type the second equation, which is square root of 1 plus x squared. Okay, so I'm trying to find out where those two equations cross. What are the x values of their intersection points? So you could zoom in. Again, if you want to change your zoom, you can do stuff like this. So zoom in. I'm just going to click over here and make it the center. I like that view a little bit better. I'm going to go ahead and change that. You don't have to do that, but I like the look of units of 1. Okay, so I want to see where those two things cross. So menu 5. Oh no, so this is menu. I like to go to geometry, points and lines, and then the intersection point. And the way that tool works is you click on the first graph, then click on the second graph. So click on the red graph, click on the blue graph, and it gives you both points. So the intersection points are x equals 0, that's the x values, and x equals 2.31. It's the x values of the intersection points, so not the intersection points themselves. Okay, know how to model word problems with algebra. So this is one of those, it looks like we're mixing some things together. So I like to draw it, kind of a picture of it. So we're going to put two, kind of vats together. We're mixing them together. So let's see what we have here. So one is like 20% alcohol solution. Add it to a 50%. And if you do the mixture right, the resulting mixture will be a 30%. And it does say that the 50% is 4 liters. So this is 4 liters. That's just the liter symbol there. So, so this one would be X liters. And I guess this would be X plus 4 liters, right? So now you have your equation. Basically, it's just going to be 0.2 times x plus 0.5 times 4 equals 0.3 times x plus 4. And now you're just going to solve that equation. So we get 0.2x plus 2 equals 0.3x plus whatever 4 times 0.3 is. I think that's 1.2. So then I'm going to maybe get the 0.2x on the other side. So we get 0.1x, and when we subtract 1.2, I think I get negative 1 there. Divide by 0.1. Divide by 0.1. We get x equals negative 10. Okay, I realized I was wrong. That's 40 right there. So that's 40, which means this is 40, which means 0.5 times 40 is 20. So this is not that. So that's 20x. So this is going to be, let's just redo that line here. So if we work on this, this is going to be 0.2x plus 20 equals 0.3x plus 1.2. So now when I do this, I get subtract 0.2, so that's 0.1x. Subtract 1.2, we get 18.8. Divide by 0.1. we get x equals, so this one is 40 also. So this is not 1.2. This is 0.3 times 40, right? So 0.3 times 40 is 12. So this is 12 right here. So this is going to be, let's keep going. Okay, so now we get on the right-hand side 0.1x. On the left-hand side, we get 8. This is working. 0.1 divided by 0.1. We get x equals 80. Okay, what's the question? How many liters? So this would be 80 liters would be the answer. Phew, sorry about that. It's early. Okay, Beth has $5 in nickels, dimes, and quarters. She has twice as many nickels as dimes, 2 more quarters than dimes. How many coins of each type does she have? So let's do kind of like pieces these, like little equations. So we have twice as many nickels as dimes. So I'm going to use N and D for nickels and dimes. So twice as many nickels as dimes. So maybe something like dimes equals, let's see, twice as many nickels as dimes. So nickels, so 2 times D, right, would equal N. And then 2 more quarters than dimes. So dimes, 2 more quarters than dimes. So quarters equals dimes plus 2. Let's see, there's 2 more quarters than dimes. Okay, we'll use this in just a minute to kind of substitute. So let's just write the equation with nickels, dimes, and quarters in there. So see, a nickel is worth 5 cents, so 0.05 N, plus a dime is worth 10 cents, so 0.1 or 0.10 times D, plus a quarter is worth 25 cents, so 0.25 times Q equals $5. So using N is really equal to 2D there. So instead of, I'm just going to substitute. So 0.05 times, I'm going to say 2D, put everything in terms of D, plus 0.1 times D, plus 0.25 times Q, which Q is really 2 plus D. I like this because it's all in terms of D now. So I should be able to solve for D. Just a matter of doing this, so 0.05 times 2. So if you're struggling with that, you can always bring out the calculator. So 0.05 times 2 is 0.1. So we have 0.1D plus 0.1D. .25 times 2, which is 0.5. So plus 0.5 plus 0.25 D equals 5. We're just solving this, so we have 0.1 plus 0.1 plus 0.25. That'd be 0.45 D. I'm going to subtract 0.5, so I get 4.5 D over here. It's kind of nice, right? So divide by 0.45. So we get so we're going to divide by 0.45. So we get D equals, and you see in the calculator there, we get 10 for that. So number of dimes is 10. How many coins of each type? So we have 10 dimes, which means quarters would equal 2 more than that. So dimes plus 2 would be 12. And nickels would be 2 times whatever dimes is. So nickels is going to be 20 nickels. And if you want to make sure you're right, you can just kind of, add that up in your head. That's $1 worth of dimes, is $1 worth of nickels, and that's $3 worth of quarters. That's $5, and that works. Now the quadratic formula uses discriminant and solving a quadratic for factoring. So in this case, solve by factoring. We'll talk about discriminant in just a minute. So solving by factoring, you first always set it equal to 0. So 6x squared plus 5x minus 4 equals 0. I would probably use AC. It's up to you. Some people don't use AC, but that's one way of doing this. Is 6 times negative 4 is negative 24. So factors of that would be 1 and 24, 2 and 12, 3 and 8, 4 and 6. They have to add up to be 5, where one's positive, one's negative. I think 3 and 8 could work. So to make that work, then 3 would have to be negative. So I'm going to split up that middle term. So I'm going to get 6x squared minus 3x plus 8x minus 4 equals 0. Do factoring by grouping. Pull out the GCF. There would be 3x times 2x minus 1 plus 4 times 2x minus 1. Because those match, we can regroup, which is going to be 3x plus 4 and 2x minus 1 equals 0. Solve, so we're not quite there, so we need to set each factor equal to 0. So that would be 3x plus 4 equals 0, so 3x equals negative 4, so x equals negative 4/3. And then the other factor is 2x minus 1 equals 0, so 2x equals 1, so x equals 1/2. So those are your two solutions. So the discriminant is this part of the quadratic formula. So this is the discriminant right there, b squared minus 4ac. So I'm just plugging in that formula. So b squared minus 4ac. So b squared would be 16 minus 4 times 1 times c. So 16, that would be plus 8, which is 24, which is positive, so there would be 2 real solutions. If you want to go further, because that's not a perfect square, I believe they're going to be irrational. You don't have to know that, but it's nice to know that. B squared minus 4ac, so it would be 36 minus 4 times 1 times 9. 36 minus 36 is going to be 0, which means there is one real solution. There are 2 real solutions. If this was negative, the discriminant is negative, there would be no real solutions. There would only be imaginary solutions. This one, if we FOIL it, we would get 3 times 4 is 12, minus 6i, minus 4i, plus 2i squared, which is really negative 1, right? These go together, so you get 12 minus 10i. Instead of plus 2 times negative 1, it'd be minus 2, which is really 10 minus 10i. You want it in real form, so we love a plus bi. So we don't like an I in the denominator, so we're going to multiply by the conjugate. The conjugate of 3 plus 5i is 3 minus 5i. So we're going to do that top and bottom. So let's simplify the denominator. We're going to FOIL that, but all we need really is first and last. 3 times 3 is 9 minus 25i squared, which is really 9 plus 25, which is 34. And I don't, oh, something does cancel. So I'm going to leave that apart for a second. Not going to distribute yet, because I see that the 4 cancels, so it's going to be 2 and 17. So we get 2 times 3 minus 5i over 17, which is 6 minus 10i over 17, which if you want to write it as like the best way here, would be 6/17 minus 10/17 I. That's probably the best form of the answer there, a plus bi, although I would probably accept the answer right there. Okay, and this one, just be careful of the negative. I might just break this up, negative 16 and square root of 25 here. Hopefully you know the square root of negative 16 is 4i, and that's 5, and so you just get 4i over 5, sorry. Or 4/5 I. Okay, so using the W technique, so this one's going to be kind of strange, or like this one you don't really use the W technique, but I think the next two you could. This one's just kind of strange. So you want to isolate the absolute value. I guess we're going to square both sides here. So this could get a little crazy. Because we have x in the radical, we need to check our answer. It's possible one of our answers is going to be extraneous. So I'm going to have to FOIL this. So if you FOIL that, you get 4x squared minus 2x is minus 4x plus 1. And this becomes a positive because negative times negative, and 2 minus x, so it would be 2 minus x. Again, I'm going to be leery of this answer, so let's get this set equal to 0 here. So we get 4x squared. Let's see, if I add x, I get minus 3x. Subtract 2, I get minus 1 equals 0. So let's try this AC method. So AC would be negative 4. Factors of that be 1 and 4 or 2 and 2. Got to be opposites that add up to negative 3, so I think that one will work. So I'm going to split up that middle term using that. So I get 4x squared. I'm going to say minus 4x plus 1x minus 1. So I split up that middle term, that negative 3x, into negative 4x plus 1x using these factors here. I put the negative first just because I wanted to factor by grouping and it seemed easier. So I'm going to pull out the 4x here times x minus 1. Plus, I'm going to pull out a 1 just because it'll make it easier to understand here, the next step. And so then I'm going to regroup. I have factored it. So I get one of them is going to be x minus 1, and one is 4x plus 1. So I get x equals 1, and 4x plus 1 equals 0. So 4x equals negative 1, so x equals negative 1/4. Put the 1 there. And I think that's what you get. But we have to check our answers. So it's probably a good idea to check these. Let's plug in 1 and see if it works. So 2 times x minus 1 is 2 minus 1 is 1. This would be negative square root of 2 minus 1, negative 1. 1 does not equal negative 1. That does not work. So that one is extraneous. We didn't make a mistake, but you just have to check your answers when you have square root of a x of a variable like that. If we plug in negative 1/4, that would be, let's see, negative 2 times negative 1/4 would be negative 1/2. Minus 1 is negative 3/2 there. Let's just do this. So I just typed both sides into the calculator with negative 1/4 plugged in. They both equal negative 3/2. So I think that does work. So this one is a keeper. That is the only answer there. There's only one answer there. So this one, I'll show you both techniques. So the first time here, maybe the next problem, use the W technique. You could use W. If you use W, W would equal x squared, that middle term. But I'm just going to factor this like normal. But instead of x and x, you've got to be x squared and x squared there. But other than that, it's factoring like normal. So this would be factors that add up to 5. They're both the same sign, so I think it'd be minus 3 minus 2. Set each one of this equal to 0, so x squared minus 3 equals 0. So x squared equals 3. Square root both sides, plus or minus. So x equals plus or minus the square root of 3. And this one would be x squared minus 2 equals 0. So x squared equals 2. Square root both sides. Don't forget plus or minus. So x equals plus or minus square root of 2. Not a bad idea to check those answers and plug them in. If you do, you'll find they work. Let's try the W method here. So whatever that middle term is, if it looks quadratic in nature, we're going to make that W. So W equals x to the 1/6. So now it's going to be W squared plus 6W plus 8 equals 0. Treat it like a quadratic, factor it. So this should be pretty easy factoring. W and W, 4 and 2. So W equals -4 and W equals -2. Now we've got to replace W with x to the 1/6. So we get, that's a W by the way, really messy W. So we get x to the 1/6 equals -4 and x to the 1/6 equals -2. We're going to take both sides and put them to the 6th power. So we get x equals whatever -4 to the 6th power is. So -4 to the power of 6. And while we're at it, -2 to the power of 6 as well. So 4096 and x equals 64 as well. These are worth checking here. So let's check these because x is underneath a radical essentially. So 4096. Let's check that. Oops, sorry. Okay, I think I see everything. Okay, so let's plug in 4096. So 4096 to the power of 1/3 plus 6 times 4096 to the power of 1/6 plus 8 does not work. Okay. 64 to the power of 1/3 plus 6 times 64 to the power of 1/6 plus 8 does not work, does not equal 0 in either case. Therefore, we can say these are not solutions, they're extraneous, there is no solution here. So be careful when x is underneath a radical, which essentially is with that 1/3 power, that's like the 3rd root of x, and the 6th root of x there. So be careful in that if that's the case, or just underneath a radical like the first one there. Going to solve linear inequalities. So there's just one little thing you have to remember with this. Let's just see if it happens here. I'm guessing it might, but we'll see. Less or equal to 12x plus 16. So subtract 2, so 12x, so that'd be 2x, less or equal to 22. Divide by 2, divide by 2. X less or equal to 11. So the big key there, I want you to see, so that is the answer there, is if you divide it by negative or multiply by negative, you have to switch the direction of sign. That did not happen on that problem. This one, I'm going to add 4 to every side there. It's kind of like 3 sides to this inequality kind of thing here. So we get 9 less or equal to 3x less or equal to 18. Divide by 3, divide each piece there by 3. So we get 3 less or equal to x less or equal to 6. So 3 right there. So x is between 3 and 6 there. Now to solve nonlinear inequalities. So this one would be squiggly line kind of stuff here. So you want to like draw a line, put your critical points, -2, 3, in this case 0, because that's a factor as well. So that's where the 0 comes from there. Plug in a point bigger than 3, like 5. So 5 plus 2 is positive, 5 minus 3 is positive, 5 is positive, positive by positive is positive. It's definitely positive. By the way, this sign tells you that all of these are open circles, so these are non-inclusive points because of this symbol there. The denominator is always non-inclusive because you can't have a denominator of 0, so even if that was greater than or equal to, the denominator would be 0 at 0 there. Plug in a number between 0 and 3, like 1. 1 plus 2 is positive, 1 minus 3 is negative, so the numerator is negative, and 1 is positive there, so negative drop to positive is negative, so it's going to be negative in that section. It's positive here. Plug in a number like -1, so that's positive, that first thing. That's negative, that's the numerator is negative. That's negative, negative divided by negative is positive, so it does this. It's also not going to bounce, you can tell, because these are all to the first power, so there's no bouncing on this graph. So I know it's going to go through, but let's just check a value like -3. That's negative times negative is positive, divided by negative, which is negative. So the graph looks something like this. We've got kind of 2 positive intervals and 2 negative intervals. Which intervals do we want? We want the graph when the graph is larger or greater than 0. Those are the positive intervals. So I need this positive interval from here to here and this positive interval here. So I would say that in interval notation, so from -2 to 0, non-inclusive, union with 3 to infinity. And again, non-inclusive because those are all open circles. So that would be your answer. Any value that plug in there will work in that equation. Absolute value inequalities. So we're going to split this up into 2 cases, the positive and negative case here. So we get 2x minus 3 equals 5. For the negative case, 2x minus 3 equals 5. So we're going to distribute that to solve that. You get 2x equals 8, x equals 4. You get -2x plus 3 equals 5. So -2x equals 2, x equals -1. And that's what you get. Or technically is an or statement there, but or just put a comma between the two would be fine. Okay, this one's kind of a special thing with absolute value inequalities. So you want to isolate the absolute value, split it up like before. So we get the positive case, 5x minus 2 is less than 6. The negative case, 5x minus 2 is less than 6. I like to put the negative there. If you put it on the right side, you're going to have to flip the direction of the sign is the rule there. 5x less than 8. So x less than 8/5. Greater, do you remember that? This is a great or. So this is an or statement between these two. So we get -5x plus 2 less than 6. So -5x less than 4. So x greater than -4/5. So this is a union. So if it was a greater sign, it would be or, but this is a less than sign. So less, just messing with you there. Less than the sign. So this is definitely an and. So if you put these two together, I want values that are smaller than 8/5 but bigger than -4/5. I would just write an interval notation. So I need something that on the smaller end is -4/5. On the bigger end, on the largest it can be is 8/5, but it can't actually be that. It's non-inclusive. So that would be my answer there, putting those together, because I want the overlap of those two. If you looked at it graphically, it would be more obvious there. How to find the domain of a function, evaluate it. So the big key there, there's 2 issues with this one, right? We've got this one can be all reals, but x can't be equal to 3. With this one, you take x minus 2 and say that's got to be greater than or equal to 0 because it can't be negative because square roots can't be negative. So x greater than or equal to 2. So we're going to meld these two ideas together. So we've got like, I might consider doing a number line and be like, okay, let's see, 3 is here, 2 is here. So this one means closed circle, arrow this way. This one, if you look at that, is going to be everything except the value at 3 there. So, and we want the intersection of these two. So like here and here, here and here. So my final answer would be from 2 to 3, non-inclusive, union with from 3 to infinity. Okay, find the function of indicated value. So this is just a plug-in problem. F of -2 equals -2 plus 1 over -2 minus 3. So this would be -1 over -5, which is 1/5. And this one, we're going to plug in a minus 2. So we get a minus 2 plus 1 and a minus 2 minus 3. So this would be a minus 1 over a minus 5. That's actually as simple as you can get there, I think. So identify the domain and range of the piecewise function at right and write the equation that is graphed. So the domain would be from, it looks like from -4 to +4, right? So from -4 to 4 brackets. The range would be from -3, goes down that low up to +3, so -3 to 3 brackets. Write the equation of the piecewise function that's graphed here. So this one is looks like a slope of -1, y-intercept of 1, 2, 3. It looks like it would cross at 3, so +3. This one has a slope of 2, it looks like, so 2x. It looks like it would cross at 1, 2, 3, 4, 5. It looks like it would cross up there at 5 if it kept going, so +5. And this one is just the equation y equals 1 here. So we've got f of x equals 2x plus 5 is the left-hand one. This one's going to be 1. This one's going to be -x plus 3. The domains of each one of those, that the first equation has a domain from -4 inclusive, so less than or equal to x less than or equal to -1. And this one would be from -1 less than x less than 1. And this would be 1 less than or equal to x less than or equal to 4. So is this defined as a function? Solve for y, takes a couple steps. Y squared equals 1 minus x. Square root both sides, plus or minus, plus or minus. So no, not a function because of the plus or minus. Got to be one function, not two. But t is jointly proportional to x and y. So if you remember like the y equals kx kind of equation, so t equals k. X and y are like direct variations, so times x times y. That's a times there. But inversely proportional to r, so divide by r. So then plug in, it says if x equals 2, t equals 25. So 25 equals k times 2 times 3 to 2 times 3 divided by 12. R. And to solve this, so when you do 25 times 12, 25 times 4 is 100, so I think that'd be 300 equals 6k. So k equals 50. So now your function rule would be the equation. So it'd be t equals 50. Remember, k is not really a variable. It's a constant. So once you figure it out, you've got to write it as your function rule. So that's your constant, find k, and that's your function rule. Now the formula for average rate of change of a function. So this is going to be f of b minus f of a. So f of, let's do it this way, 2 plus h minus f of 2 over 2 plus h minus 2. So let's plug it in. What do we get up here? So f of 2 plus h, wow, that's going to be 2 times 2 plus h squared minus 2 times 2 squared. Okay, over, that really simplifies to be just h down there. Oh, I like that. You got to FOIL this guy, so that's going to be 2 times, if you FOIL that, you get 4 plus 2h plus 2h is plus 4h plus h squared, minus 2 times 4 is 8, all over h. So we get 8 plus 4h plus, or sorry, plus 8h, because that distributes, plus 2h squared minus 8. I like this. It's simplifying nicely. So we get 8 minus 8 is 0. So we get 2h squared minus plus 8h all over h. Factor out the h's up top. So that'd be h times 2h plus 8 all over h. The h's cancel. So I think you get 2h plus 8. Oof, very nice. Determine whether it's even, odd, or neither. So the plug-in there is negative x. So I'm going to plug in negative x and see what things change. So 2 times negative x, that's going to change, plus 1 over negative x. So this is going to become a negative 2x minus 1 over x. So everything changed there. So if everything changes, it is odd. Everything changed odd, so it's an odd function, which kind of makes sense because this is to the first power, this first power, but I was a little concerned about the denominator there. If you're not used to that, that's just got to do the formula and see what happens. If it was the same, nothing changed in the signs, it would be even. So sketch the graph. So what's moving here? So this looks like it's moving to the left 1 and up 1. So I'm going to take each of those points and move it. So like to the left 1, left 2, sorry, left 2 and up 1. So that point moves to there. This point started here, moves to the left 2, up 1. And this point started here to the left 2, up 1. And then you make your function. So negative 1/2 x. So you could, not a bad idea to write out the ordered pairs of the parent function here, which would be 0, 3. Talk about these 3 points. 1, 0, 3, 1. Multiply all, this should take care of it. If you multiply all the y values by negative 1/2, I get negative 3/2. I get 0, that doesn't change, and negative 1/2. So I'm going to plot those points. 3, negative 1/2. 1, 0, that didn't change. Actually, that point's the same. And then 0, negative 3/2, like this one. So wow, it just kind of like did weird things here. So this is what the function looks like now. So it kind of oh, that's interesting. Yeah, it has a different look to it now. The stretch of it, that negative 1/2 really kind of squished it a little bit, made it wider. So it doesn't even look like the same function really, but it is. It's just been reflected over the x-axis and then vertically shrunk. So this one, you could do this a couple different ways. If you really like completing a square, you could do that. I'll take the easy route here and do the HK method. You might want to have this example in your notes. So opposite of B would be 4 over 2A, which would be 4. So H is 1. K, to find K, you just plug in. So everywhere there's an X, you're going to plug in 1 here. So 2 times 1 squared, or 2 times 1 is 2, minus 4 plus 5. So that's 7 minus 4 is 3. So I think you get the point 1 comma 3. That's your vertex. And let's see, so you're going to have a 2 is your A value. So instead of going over 1, up 1, I'm going to go over 1, up 2, over 1, up 2 the other way. That's probably enough points. We don't really have enough for another. We would go over 2, up 8, but I'm out of room there. That'd be a pretty good graph there. Find the composition of functions here. So we're going to compose. So let's do the inside part here. So this would be f of, let's see, g of negative 1. You can just probably do that in your head. Negative 1 squared is 1. 1 plus 5 is 6. Plug that into the f function where there's an x right there. So this would be 2 times 6 plus 1, which is 12 plus 1 is 13. So I think we get 13 there. The inside part, f of 3, 2 times 3 plus 1 is 7, so g of 7. We have to do that in our heads. 7 squared is 49 plus 5, which is 54. And this one, we're plugging in g of x here, so f of g of x is x squared plus 5. So now everywhere there's an x, we're going to plug in x squared plus 5. So we get 2x squared plus 10 plus 1, which is 2x squared plus 11. Now, definition of an inverse of a function, definition of one-to-one function, and how to find the inverse of a one-to-one. Okay, so on this one, just find the inverse function. So what I like to do is plug in the y there, switch x and y, solve for y. Divide each term by -5. So you get y equals -1/5 x plus 4/5. If you want to think about it in slope-intercept form, you could have it written a little differently if you wanted to. So yes, this is a function. It passes the vertical line test. It doesn't cross it more than one time. To be one-to-one, it has to pass the horizontal line test as well. It does not pass that test. So this is no, it is not a special one-to-one function. It's got to pass horizontal line test and vertical line test. So this is one of those sketching. This should be like current stuff, so maybe not quite as difficult as some of the other stuff you've done just because it's more recent. So 2, -1, and 1 would be my solutions. The end behavior, x to the third, is the first term. So that's to the left is down and to the right is up. It looks like it's going to go through. So, I mean, I'm picturing it's going to go through there. It's going to go through here. I might find the y-intercept. That's the thing we haven't done yet. So to find the y-intercept, plug in x equals 0. So that'd be -1 times 0 plus 1 is 1 times 0 minus 2 is -2. So the y-intercept would be +2. So now we have enough points. There you go. That's pretty good. Pretty good sketch of that graph. Find the local max and min in your calculator. So let's try this one. Hit the home key, go to graph. Negative 2x to the fifth plus 3x squared minus 2. We want to find the local minimum and maximum. So menu 5.1 looks like that's a maximum. And it doesn't say the word minimum, but it does say y-intercept right there. So I'm assuming that's both the minimum and the y-intercept. I think that's a safe assumption to make. So the location, so this would be 0, -2, and 0.843, comma, -0.72. And I think it just said to find the location, so we want the actual ordered pairs there of the, this was the min, this was the max, I believe, the local min and the local max for that one. Almost done. So long division and synthetic division, I think those are our last two problems here. So, and again, this should be more recent stuff, so you should be fine on this. Probably a good idea to put a 0 in there. You can see we're missing a term in between the x cubed and x there, so I think that'd be a good plan. So I put a 0 in there for 0x squared. So x squared times 1 is 3x to the fourth, that would be 3x squared. So I'm going to put that in the x squared column. Multiply that, so you get plus 3x to the third plus 9x squared. Negative 8x to the third minus 9x squared minus 20x. Bring down the next term. You can bring down both of them if you want. That'd be minus 8x. So you get negative 8x cubed minus 8x squared minus 24x. You're going to subtract everything there. So you get negative x squared plus 4x minus 5. Okay, x squared times that is minus 1. So we know we're done up there. Negative x squared minus x minus 3. We're subtracting everything. So you get 5x minus 2. That's a remainder. The answer would be 3x squared minus 8x minus 1 plus a fraction. The remainder, 5x minus 2, divided by the divisor, which is x squared plus x plus 3. -2, 11, -12, -5, 20. Okay, so -2, -8, 3, that's an 8. 12, oh, we like that, 0, 0, -5, -20. So remainder is 0. This is my x term, this is my x squared term, this is my x to the third term. So I get negative, this is a factor, by the way, plus 3x squared minus 5. And we got it. Ooh. Wow, took a while. There we go.